It might happen that we call a friend not knowing he's at the bottom of the garden preoccupied with something really interesting. We wait and wait till at some point we just can't wait any longer. What now? Can we cancel the invite? Of course, by simply hanging up. Now, in this module, we'll study the cancel request and how it's used to cancel a pending invite. You know a lot about SIP by now, so why not take a moment and make some predictions? How do you suggest a pending call will be cancelled? How will the call flow look? Give it some thought, then make a test call for yourself and have the caller hang up instead of having the callee accept the call. Then study the logs, comparing the actual call flow with your predicted call flow. Press play when you're ready and we'll compare notes. So here's my user agents. Alice calls Bob, but before Bob answers, I'll have Alice hang up. And the call flow, there's an outgoing invite, a returned 100 trying, a 180 ringing, and surprise, surprise, an outgoing cancel. Easy, just as predicted. But what next? Well, there's a 200 OK and a 400 type response and an ACK. Interesting. Let's unpick the call flow and look at the cancellation process. After the invite, the 100 and the 180, we saw the cancel request, followed by a 200 OK. But a 200 to what? Well, we know because we made the call, but simply looking at the messages in the log, it's not immediately apparent if it's for the invite or for the cancel. So how can we tell? We can tell through the CSEC method. If the responses CSEC method contains cancel, it's a 200 OK to the cancel. If it contains invite, well then it's a 200 to the invite. In the test call just now, the 200 had CSEC cancel, meaning that the downstream user agent has received the cancel. It's not a 200 OK to the invite. Now, do you remember the definition of a transaction? Well, a transaction begins with a request, ends with a final response, and includes any provisional responses in between, except for the ACK. And that's true for the cancel transaction. It begins with the cancel request, ends with the 200 OK final response, and typically has no provisional responses in between. But what about the invite transaction? It still has an outstanding final response. But what kind of response should we expect? Well, why not click here for the RFC, scroll down to page 5, and look for the final response we'd expect in the invite transaction following a cancel. Go ahead and press play when you're ready. Having been cancelled, the invite was not a success, meaning that we'll need some kind of error or failure response. And because the response is issued by an endpoint user agent server, the first place to look is the 400 client error family that reports error from a user agent server. Scanning through the list, we see the 487 request terminated. That's the response we'd expect in the invite transaction following a cancel. Talking of transactions, what about the ACK? Which transaction does the ACK belong to? The cancel transaction? Perhaps a self-contained ACK transaction? Or is it part of the invite transaction? Well, applying the rules, we know that an ACK only ever follows an invite request, buying time for user input. There's no need for user input with a cancel, so the ACK is not part of the cancel transaction. Is it a self-contained ACK transaction? Well, an ACK after a success response is certainly a separate transaction. But, and here's a new rule for you, an ACK after a failure response is not a self-contained transaction. An ACK after failure actually belongs to the invite transaction. We'll look at why in more detail later after discussing forking. It's also worth noting here how transactions can be nested. The cancel transactions nested inside the invite transaction. Okay, one more point. It's possible that two or more requests could be received in very close succession, followed by a cancel. Now, how does the downstream user agent server deduce from the cancel message which of the requests is being cancelled? Now, it can't use the CSEC method like it did with responses, because requests always have the same method type in the start line and the CSEC header. So the CSEC method doesn't tell which request is being cancelled. The key here is the CSEC counter. The counter in the cancel always matches the counter in the cancelled request. So in summary, user agent clients can cancel pending requests by issuing a cancel request. User agent servers immediately respond with a 200 OK to the cancel, reporting that the request was delivered reliably and that it knows to stop alerting the callee. Final responses to the invite and the cancel are differentiated by the CSEC method. The final response to the invite has CSEC something invite, whilst the final response to the cancel has CSEC something cancel. The cancel transaction comprises the cancel and its 200 OK, whilst the invite transaction comprises the invite, the 100, the 180, the 487 and the ACK. Remember, following failure, the ACK always belongs to the same invite transaction. On receiving 2 or more requests, then a cancel, the downstream user agent server uses the CSEC counter to deduce which request it needs to cancel.